Let's first start with compound inequalities. What are they? Well, basically, they're more than one inequality separated by two logical connectors. We've got the AND logical connector and the OR logical connector. And you can imagine what they mean. In the case of AND, both of the inequalities on the left and right side of the AND have to be true for the entire expression to be true. And in the case of OR, either one can be true. So let's work through some examples. Okay, here we have a compound inequality that involves two different inequalities on the left and right of this logical connector AND. For this entire inequality to have a solution, both of these inequalities need to have a solution. And this number line here represents all the values that x can be. And in the case of 4x plus 1 is greater than or equal to 9, x can go from 2, and the expression is greater than or equal to. So in that case, if you remember, we write a dot and circle it in, and then we're just going to write a line here that goes on forever. Okay, now let's look at this one on the right. X is less than 4. Well, x is already solved. We know what it is. It's defined as anything being less than 4. Start at 4, but not include 4, so we don't fill in the circle. And then it's going to be anything here below 4. And because we're working with a compound inequality that uses an AND, the only solution to this entire inequality is going to be where both of the solutions of the inequalities overlap. And we can see that that is right here and right here. So this is the solution for this inequality. Now let's look at some OR cases. Here we have two inequalities where if there's a solution for either of them, then the entire inequality has a solution. So let's map this one on the number line. Here x is defined already. Let's go ahead and plot that range, and that is going to be the circle not filled in, going forever in the negative direction. And then for this inequality, 4x plus 1 is greater than or equal to 9. So that solution is going to be, well, what x's satisfy this? If x is 2, and we put that into the inequality, well then 4 times 2 is 8, plus 1 is 9. So that would be the minimum value of this inequality. So let's go ahead and start there at 2, x being 2. And again, this is greater than or equal to, so we're going to keep going forever in the positive direction. And so this is what an OR inequality looks like. Now we can think of doubles as AND inequalities, but with a shared term on both sides, and I'll show you what I mean. So let's actually write down an AND that has shared terms. Let's use our 4x plus 1 again. So here we have the same expression on the left and the right side of this AND inequality. And so what we can do, if we want to, we can consider this as a double. And the way doubles are written is you take that shared term and you just can put it in the middle. Well, 4x plus 1 is greater than or equal to 5. So because it's greater than, let's, on the left-hand side, we're going to put that operator right there. And it is greater than or equal to 5. And then on this right-hand side, 4x plus 1 is less than 13. So we're going to write our operator right here, and we are less than 13. And so a double inequality sort of just has these values in order from least to greatest, typically. And then the double just comes from the fact that we have double the amount of inequality operators as usual. What does this one look like on the x range number line? So if x is 1 over here, so that would make that term 4. And 4 plus 1 is greater than or equal to 5, and actually it's the bottom of that range, which is going to be when x is 1. Our number line here is just the range that x can be. Okay, so we know it can be 1 on this left side, and it goes to the right here forever. And then what might be the upper range, since 4x plus 1 is less than 13, let's look at the high range of that. Does it fall within the range of the inequality on the left. Let's think about it. So what if x is 3? If x is 3 here, 3 times 4 is 12, plus 1 is 13. So that's going to be the top range of this inequality. I'm going to write that open circle again. Let's go ahead and draw our line all the way to the left, going on forever. And again, we're looking at, because this is an and, we want to find the places that they overlap, these two inequalities. And for us, that is going to be the set of numbers 1 all the way up to 3. And I'm not sure if you've seen this notation yet here, these brackets and these parentheses. And if you haven't, I'll quickly explain that the parenthesis on the right is not including. And the bracket on the left-hand side here is including. So this is just a simple way to write a range of numbers. And we can also write that on a number line. So we're going to fill in our circle. We're going all the way up to 3, but not including 3. So we're going to keep that circle not filled in. These two are equivalent. And I think we have a good grasp on what compounded double inequalities are. In the next video, we're going to practice solving all the inequalities that we've learned about.